in this video, I will explain you the concept of electric field line. In the last video, I have explained what is electric field at a point. Electric field at a point is nothing but force experienced by a unit test charge. Unit test charge means 1 coulomb test charge placed at a point. So let's say we have a charge of Q here. We will keep a 1 coulomb of charge and we will calculate the force at that point, which is F is equal to 1 by 4 pi epsilon 0. Q into 1 is 1 itself divided by R square. So this is force and this can be taken as electric field because it is defined for 1 coulomb. So electric field is this one, and we got one equation for force as well. So for 1 coulomb, if force is E, now for Q coulomb, force will be QE. And with this force, if it is positive, we know that it will move in this direction. Now electric field line has been defined in this way. It's an imaginary lines which represent electric field at a location. Now we know that electric field is a vector quantity because force is a vector quantity. What is electric field? Electric field is equal to force divided by a scalar quantity, charge. So electric field is a vector quantity. Now see, at this point, what is electric field? Away from 1 coulomb, okay, or away from the source charge. At this point, what is electric field? See, if I am keeping a charge here, it will be repelled in this direction. If I am keeping a charge here, that will be repelled in this direction. If I am keeping a charge here, that will be repelled in this direction. So this is the direction of electric field. So at this point, what will be the direction? This is the direction of electric field. Now these lines are called as electric field line. So it's an imaginary line which represent electric field at that point. There are no lines existing in this way, but when we see an electric field line in this way, we know that if we are placing 1 coulomb, that will be moving in this direction. Okay, so if electric field lines are in this way, which means when I am keeping 1 coulomb, then that 1 coulomb will be moving in this direction. Okay, now we will see the properties of electric field lines. So which are the basic charges? We know positive and negative. So here positive Q and negative Q I am going to consider. Now first property is from where electric field line will start, from where electric field lines will end, starting point and termination point. So with respect to positive charge, if we are keeping a 1 coulomb here, we know that this will be repelled in this direction. Plus 1 coulomb here will be repelled in this direction. Plus 1 coulomb will be repelled in this direction. Now one thing is very sure here, starting point is from positive charge. Now if I am keeping a plus 1 coulomb here, then that will be attracted inward. Plus 1, this is negative, attracted. Plus 1, this is negative, attracted. So where is the point the electric field lines are getting terminated? That is on negative Q. From positive Q, electric field lines are started, and on negative Q, electric field lines will terminate. So first property is very clear here. Okay. Now if you are keeping positive charge and negative charges near, positive and negative in this way, plus Q and minus Q, how will be the electric field line here? Then that will be from positive to negative, positive to negative. This is the direction of electric field. Next thing is very important. Direction of electric field at a point is tangent drawn to field line. Now when I am keeping a positive plus 1 coulomb here, in which direction the charge here? It can be any force. For example, I am keeping a plus 2 coulomb here, or let's say plus 1 coulomb itself. Okay, plus 1 coulomb here. Now to get the direction of electric field line, just keep the charge here and draw a tangent to this point. Then that will be the direction of movement of positive 1 coulomb. That is nothing but electric field line. Okay, so how to get the direction of electric field here? See, if I am keeping, which means that in which direction 1 coulomb will move, that is the direction of electric field line, right? What is the direction of electric field line? In which direction a 1 coulomb will move when it is placed at a location P. That is electric field line. direction of electric field at point P, right? Now the direction of electric field at this point will be tangent. At this point, tangent. At this point, tangent. At this point, tangent. Which means when I am keeping 1 coulomb here, it will be moving in this direction. If it is negative charge, it will be moving in otherwise in opposite direction. But we know that electric field has been defined for a test charge of unit magnitude. Okay, so direction, how we will get? Just get the tangent of electric field line at a point, we will get direction of electric field. From field line, we will get direction by drawing the tangent. Next thing is relative strength of E. So we know we have a positive charge here. So what is the value of E? E is equal to, we know 1 by 4 pi epsilon 0 Q divided by R square. This is E, right? So this equation itself is saying that when we are increasing R, when we are moving away from it, field will decrease. But this can be easily understood with the help of field lines. Now from positive, field lines will be in this way. Starting from positive, right? So similarly, we will have it here as well. Now keep a ring here, okay, a fixed ring. So I am keeping a ring here. So the ring encloses 4 electric field lines here. Now the same ring, if I am keeping here, it encloses 3. Now the same ring, if I am keeping here, it encloses only 2. Now the same ring, if I am keeping here, it only encloses 1. It's the same ring, but when I am keeping here, more field lines are passing. The density of field line is more, but when I am keeping here, less. So this density represents intensity of electric field at that point. Okay, so relative intensity can be measured in this way. Exact value cannot be measured, but I can say that intensity is more at this point as compared to this, because here it is 1, here it is 2. Intensity is more at this point as compared to this, because here it is 2, here it is 3. Intensity is more at this point as compared to this. Here it is 3, 4, here it is 3. Okay, so this is well explained now. Now they never cross each other. So for example, we have one more positive charge here. Now in which way we will draw electric field lines? It will be away from positive charge. But see, as per our thing, if we are keeping field lines in this way, we know that at field line, anywhere if I am placing 1 coulomb, just draw the tangent at that point. That will be the direction of movement of 1 coulomb. So here if I am keeping 1 coulomb, in this direction it will be moving, because tangent is along the same direction, right? But if they are crossing, then if I am keeping 1 coulomb here, in which direction it will move? Because here we have 2 field lines at this point, one in this way, one in this way. It creates an ambiguity, right? In what defines in which direction our object will move, our 1 coulomb will move. As it creates an ambiguity, we have defined that electric field lines will never cross each other. If they cross, at the point of intersection we have 2 directions. That is not possible. We can only have 1 direction, because electric field line has been defined as the direction through which 1 coulomb will move. But here there will only be one direction through which 1 coulomb moves. There won't be 2 directions. So crossing or intersection of charges is not possible. So here in this case, how will be the electric field? If you are keeping +1 and +1 here, so field lines will be, here it is radially outward, here also it will be radially outward, but here these field lines which are supposed to be radially outward, they will interact, and that will be in this way. So these field lines will repel each other. See, these field lines will repel each other. They will never intersect. See, they are in this way. With negative, it is coming. See, negative, it is in this way. So electric field lines will never cross. Intersection is not possible. So this is explained. Now starting and terminating angle. This one is very, very important. Okay. So let's say we are giving some certain positive charges to a shell. So we know if it is metallic conductor, these, see, if I am keeping the positive charges here, metal will allow movement of charges. So these 4 positive charges will repel and the positive charges will be at maximum distance apart. So instead of 4 positive, if it is 10 positive, that will be in this way. So it will be on the surface. Now, see, there are 2 possibilities here. One way is electric field lines can terminate at an angle 90 degree from the surface. Next thing is electric field lines can terminate at an angle of theta from the surface. Now, if this is the case, then E will have 2 components. One can be split in this way and another can be split in this way. So one is along the surface and other one is normal to the surface. Now if at all if there is electric field in this direction, what will happen? See, we have positive charges here, right? These positive charges will move across. Will that possible? No. If at all, see, if we are giving charges on a sphere or a metallic conductor, that will reside, simply it will stay at rest on the surface. It will not be moving. So if at all electric field is in this direction, it will have a component in this direction and with that component charges will be moving in this direction. That is not possible, right? So electric field lines are in this direction, perpendicular to the surface, so that it is not having any component along the tangent, so that these electrons or these charges will not be moving. So with positive charges, it will be, see, along the radius. So always radius is perpendicular to the tangent. So it have to be radial. See, this is radius and this is the tangent. Radius and tangent is perpendicular. See, so with positive, that is the reason we are saying that it is radially outward, with not just saying outward, it is radially outward. Okay, so with the negative charges, how will that be? With, this is the case of positive charge, right? With negative charges, it will be exactly perpendicular to the surface. This is the tangent drawn at the surface, perpendicular to this. Tangent, perpendicular, tangent, perpendicular, tangent, perpendicular. So it is inward. So all these 5 points are very, very important. This has asked many times in your board examination. Okay, make a note of it. Thank you.